Oh, this too. My name is Kyubyung. Always go by Q. The professor in the School of Construction Management and Technology at Purdue University. So the topic that I'll be discussing today is falling objects that reach effectively 30 and 50 kV at construction site. So the work story from the pump project in the class that I'm teaching, the whole thing is computer vision for small construction management. So that's why you see many names up there, 3 students and 3 advisors. So it's a collaborative work, but still it's a town project. So it's feasibility checking type of research instead of content. So according to the International Safety Framework Association, the worker in the United States gets struck by the falling object in every 10 minutes. The number shocks me. It's not only the construction site though, but any occupational site. So we looked at the numbers and so we did our homework. Then they looked at the literature reviews and what kind of studies done to identify the falling object. Surprisingly, we didn't find much of research focused on the falling object. Meaning is that a lot of research is focused on the workers itself. So let's say I'm a worker in the construction site. A lot of video cameras or these computer vision technologies looking at me as a worker and identify the posture or the feelings or the different colors and so on and so forth. But there's not practical tools to identify falling objects from the top of building, top of structure, whatsoever. But why do we need to identify? So according to the OSHA, every project site should report if there's a near miss dropped by any object. Like near miss means like there's a falling object here, didn't really hit, nothing happened, but it happens. It could worse. It could be accident if the object falling to me is hit me or I was struck by the object here. So, but the thing is, lack of resources, lack of human resources, lack of time. Not many construction sites actually report to the OSHA. All they observe nearly. So we wanted to help the construction site to see, put the CCTV camera, really cheap CCTV cameras, just watching the construction site 24 hours, every 24 hours, 7 days, and looking at the identify just object that is falling from the structure, the construction site, right? So we also looked at what kind of studies use the CCTV. There are actually a lot of them, but again, they looked at the workers here, or identify the some object with workers, like for that, identify the gloves. Probably a lot of you looked at the research already, but not single the open source data available to use for this research. That is the type of the object that is falling from the top. So we decided to use the OpenCV packages and create some of the data to train the model and develop a framework. So the purpose is simple. Purpose was is to detect the object. We don't know what it is, but the object that is falling to the ground and using the CCTV camera, which is relatively low resolutions. So we came up with the 3 steps. By the way, the students tried to use the different available algorithms to start with, but it didn't work well. So I can explain why in the later slide, in the limitation slide later. So we start with the 3 steps. One is the background elimination. So we wanted to identify the object which is falling, right? We don't want the computer look at the background of the object that is falling, so then to use the unnecessary computer resources. Then the second is actually detect what it is and the tracking, how fast it's falling and where it's falling to. So the first step is to remove the background. Probably some of you understand the structure from motion. And the structure from motion used to identify the feature point of the images and in the consecutive frames or images matching the feature points. And we use that technology to remove the steady background of the CCTV camera. So the thing that you see that one of the students just throw the boxes in the motion construction lab at Purdue and identified what the computer identified what the steady background and the things that's moving. Computer doesn't know what it is or the object though at this point, but computer knows what's moving, what's not moving there. So the very first step, we need to know what's the staying in the consecutive frames. Morphological opening helps to reduce the noises, and what that means is if you're looking at the object and dealing with the full perfectly circular shapes, although it rotates, it's the same shapes. So it creates noises as that full shape moves forward. But if we look at this one side is longer than the other side. So when it rotates, it's easier to understand something is moving. The second step is to actually identify the object is moving. So it's the same thing, the first frame, the second consecutive frame. And let's say the first step, identify what's not moving, what's moving, and create a contour line. Contour lines is to know where the moving object are located at. And here in the consecutive moves, consecutive images, what kind of that is moving forward. So we create in the second step, also identify what is, second step doesn't identify what it is, but second step knows it's moving. So draw the boundary boxes in the second steps. The third one is to actually identify, oh, the object is falling. How can we identify the object is falling? Definition is to drop it. We can, in the human vision, human mind, we can just explain, oh, it's falling. But definition of falling is vague. So what we did as a research team is draw the two lines. It's a very simple solution. So it's kind of catching, but we are hoping to come up with a better solution later. But let's draw the two lines. And once we identify the object with the bounding boxes from the first and second step, pass the first line to the second line, and we define that as a falling object. So the simple tool, the idea we started is to help the construction site managers to constantly monitor the construction site to identify how many falling objects are happening in the site. So this simple tool created by one of the team members is actually count how many objects are falling in the one CCTV video footage. So let me show you the result first and come back to the limitation. The experiment setup is following. So we did a simple experiment and actually we used the 20 video footages, or we recorded tons of them and did a try and error runs and to see what kind of things can be captured better in the situation like this. So it was 12 feet tall. It's more than the single story tall like this one. I think this is about 20 feet tall, the ceiling. And on top of that ceiling, there is some opening spaces here. The student was sitting on top of this balcony type space in the room in the construction lab, and through the object, the random object following these pictures and the video, the CCTV was set at the other side of balcony and looking at that students and trying to demonstrate the object, the framework that we developed. And this is the result. So you can see the object is starting from the beginning, didn't capture the bounding boxes. It's calculated to see what it is. And once it passes the second step, identified, oh, that's spiraling, and draw the bounding box. And it passes, not sure you can see the numbers here. And it counts like 75. So we draw the object multiple times and tested it. The tool can actually count the object or not. All right, so this is the last slide. I'm not sure I can come back to the slides showing the limitations, but basically the morphological opening helps the identify the object falling. And the second is a small object, like smaller than the 5 by 5 pixel in your fridge, creates a lot of noise. So if you throw the small object from this level to the ground floor, the tool didn't work very well. So we are working on that to make that, to identify small objects and the better accuracy. So again, we used only 20 video fridges, but we did a lot of them and just showing the best results. So it actually works well, but the test was conducted in the controlled area. So kind of hoping for doing the demonstrations in outdoor, in real world conditions. All right, thank you very much.